Hello everyone, just a very small prefix for the pre-recording because this contained a live demo. Of course the software to record the live demo didn't work, so you guys are all going to enjoy it, but unfortunately whoever's watching this elsewhere won't. Hello, my name is Tom, that's my terrible profile picture. I'm the Chief Security Officer of Cush Security. I've been working in cyber security now for, about 9 years, and you can see my various qualifications and bits and bobs on there. Who is Cush Security? We make a enterprise-grade AI-powered human-centric DLP solution, which is the best collection of buzzwords you've ever seen. But in general, feel free to come chat to me after the talk. It's a very, very, very good piece of software. It has a lot of EDR capabilities as well, and we have an extensive policy engine where you can write weird stuff like if a user in my dev team tries to upload source code from their personal G drive on their work laptop, then block the upload, display them a notification, require them to enter a business reason, and click a link to read your acceptable use policy because that's not allowed. And it supports Linux. Which is number one. Well, there we go. Now I've got them. So what's up with the title? It's an absolute mouthful. It's terrible. But I hear if you have a talk, you have to have a really good title. So this is my attempt. It's based on some security research I did a few years ago. You can see the CVE there. We're talking about from zero. So we're talking about basically the entire security research process. End-to-end is what I'm going to be covered here, somehow in 30 minutes. SSRF, which is server-side request forgery, and RCE, which stands for... remote code execution. And back again, because we're going to touch on some real-world impact at the end of this. As again, this is a live demo, so hopefully it works. We're going to go through, this is a photo I took with my phone a very long time ago. We're going to go through end-to-end the ethical hacking methodology. So first off, information discovery. You want to hack a thing. What do you want to hack? I'd recommend you pick something fun. If any of you do this as a day job, you probably don't have that option. I recommend picking something that has easy access to support and documentation, just because this is the first time you're going at it. Try and go easy on yourself. Real-world impact is really good, and please check beforehand you have a way to report the bug, otherwise you'll go through all this problem and you won't be able to report it. And then why are you doing it? Are you looking for monetary? Are you looking for a CVE? Do you want to get in like Google's Hall of Fame? Do you want to do it for fun, or do you want to sell it to government? There's a line at the end there. I picked IBM Data Power. This is because I was an ex-IBM employee and I really like this piece of software, and it kind of ticked all of the boxes. It was fun, easy access to support, real-world impact, and really I wanted a CVE under my name. Is the video going to work? Yes. So what is Data Power? It's basically a API gateway, so you can feed it in JSON or XML or stuff like that, and it'll validate it, and then you can send, for example, a GIF, and it won't like that, and it rejects it. It's a surprisingly interesting piece of software. I recommend you give it a Google because it just does literally everything security related ever. And it's extremely hackable and extensible, and it comes in lots of different form factors. A physical box if you're a bank and you want to process 50 billion transactions a second, KVM, and the most important thing is there's a Docker... Oh, the video stopped. There's a Docker version of this, which is hey! The Wi-Fi here is great. And there's a Docker version of it. It's free on Docker Hub. You can go and give it a go, etc., etc. Next slide, please. Why specifically did I pick this product? It's because it's hardened by design. It's not designed for you to get into it because it's the sort of thing that's used by banks to do transactions at really high speeds. It has lots of crypto in it. It's where you're going to be storing a lot of your crypto keys. If you forget the password, you have to physically ship the box back to IBM and they do some magic and then everything's good again. And it's very, very locked down. And because it was a tough nut to crack, I really wanted to attempt to crack it. So that's kind of the information discovery process. So let's use it. This is the bit where it goes horribly wrong. So what we're going to do is, this is the Docker run command. I've pre-downloaded this image because it's fat. And has some various command line options there. It's not really important apart from Docker run data power, please. And it will hopefully start. So there it is. And it's coming online, and it says unauthorized access prohibited. And then when it starts, you get a login prompt. Who wants to guess the username? Oh yeah. And what's the password? Oh, amazing. We're in. That's the end of the demo. No, it isn't. So we're going to, interestingly about data powers, you can mistype pretty much everything and it still kind of says, I know what you mean. So we're going to do that. We're going to go into the web management, and then we're going to do admin state enabled, kind of conveniently. We're going to exit that. We're going to save it. Hopefully you can see this. It's saved, and then we're going to show. What are we going to show? The thing I just typed, the web management interface, and you can see it's up. Kind of interestingly, you have to do this. It is like a secure by design appliance. So if you don't want a web GUI, it won't give you a web GUI. We do want a web GUI, so here's a web GUI. Of course, we haven't configured any certificates yet. Continue that. Log into it. And you will see a UI that looks like it was designed in the 80s.
It's IBM.
Shocking. It's still loading. Give it a moment. It's loading. There it goes. It's beautiful. So that's basically it. But set it up. It works. Cool. Some interesting things that just happened there. We logged in with admin. So you can easily break into any unsecured Docker containers that are running in the development environment just off the bat. And interestingly, you probably go on Shodan and just type in data power, and you may find some of these, which is kind of interesting because it's the web GUI for a gateway appliance. It really shouldn't be there. So target scanning. So this is a Docker container. The reason why I kind of picked a Docker container is we can break it apart and find a really good target to play with. So let's break it apart and find a good target to play with. Who knows how to get inside a Docker container? Yes. I'm going to spell Docker correctly. So we're going to Docker and exec inside. My spacebar is broken, by the way, so that's the reason why I keep on mistyping it. And here is the process listing of data power. Interestingly, there's not a lot in there. There is a single binary that runs this entire application, which is amazing. It's huge. There's this thing called quota enforcement. There's dpmon, which if I put an N there instead of dp, what's that? Nmon, the performance analytics tool, so they just kind of made their own one, which is kind of cool. And then they have two things here, which is Redis, which is kind of interesting. Something you could do, like straight off the bat, is you could just take that binary, you can then go and throw it into some piece of software, you can disassemble it, and you could spend the rest of your life in here looking for all the disassembly and strings. But, this is a possibility, something that you could do. And I'm going to remember where my slides are. So there you go. What's running? What's on the file system? We've kind of broken into the container. We have a look around. We can reverse engineer. You can do some string search. You can just do web scanning of the web GUI as another option. There's also a telnet and an SSH interface, which I haven't enabled for this demo, but that's another place that you could look. But Redis looks like a good target, just because it's the only open source piece of software that's kind of there, and it's open source, so it's easy for us to go and Google things about it. So making progress now, so we can target scanning. Now we're going to move into the vulnerability assessment. Is Redis vulnerable? Let's find out. Ignore. So the reason why that this is here is because last time I forgot this, but I remember to put it in the slides. So we're just going to netcat, so we're going to connect to this locally running Redis instance. And does anyone here know the command to get the version of Redis? Nope. It's status. No, it's not. It's info. False. We need a password. Where can I find the password? Who said that? Bad. That's a bad thing that you shouldn't do. Let's go and find the hard-coded password. So we're just going to look for the Redis configuration file. There's the Redis configuration file. And there's a hard-coded password. Now, to be fair, this is a Docker container, so this password could be dynamically generated each time the application starts. Or it could have some sort of cryptographic thing where it's like tied to the MAC address or something like that. So we need to confirm that is this actually hard-coded? Because basically it's holding all of this inside of a RAM disk, so it's a little bit here and there. So conveniently I have the string search table already loaded, and I'm going to put that in there, and we're going to search through the data power binary for a hard-coded string. It's just like the movies. Ta-da! It's in there. So yes, it's a hard-coded password. So we did the info command. Oh, I just need to type in the password. There we go, we're in. And then if we scroll all the way to the top, we have the version of Redis here. So we got some information there. I did a bit of information gathering. We kind of know what we're doing. So we have Redis. So basically, the next step, I just googled Redis exploits because there's got to be some Redis exploits out there for this version of Redis. This chap, however you pronounce that, did a really, 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 really good paper and presentation on all different ways you can break into Redis. I highly recommend you reading this. Good security research is always built off the shoulders of giants. And this is basically the rogue Redis attack, where what you do, you have a Redis server that you have some sort of control over, and then you run your own rogue Redis server. And the idea is you basically set the config or the save file for Redis as a shared library. And then you tell that Redis server to be a kind of a replica of your master, which is this person here. And then you say to him, I want to do a full sync, forget everything you know, I'm going to give you your new Redis database. And you don't send a Redis database, you send a reverse shell instead. And then you say, save that, and it saves it to the file system, and then you say, load it. So then you can load your own malicious code into Redis, which is amazing. So it's like, cool, so we have a potential here for remote code execution. Don't know why I exited the slides. So this is a crazy powerful exploit. Any Redis server that is on the internet is vulnerable to this. So you can just connect, and then you can execute remote code on that host. Redis introduced protected mode to prevent kind of a lot of attacks surrounding this thing. So by default, it only listens to the local host. And if you actually read the Redis security guide, it recommends disabling a lot of commands in Redis. But by default, all of them are kind of available. Do you think people follow any of this advice? Good. So if you go on Shogun right now, you might be able to find some vulnerable Redis things. So it looks like a really good target. However, there's a problem. It's listening on localhost. And we don't have access because we're not inside the Docker container. We want this, we're remote, we're somewhere else on the internet. Interestingly enough, this is not the protected mode. This is the data power team hardening their appliance because they knew that this should remain an internal process. So there we go. So we've now done a vulnerability assessment, and now we kind of want to exploit the weakness. So it's listening on localhost. We need a server-side request forgery for this. There's a really good link there if you want to read more about this, and the good Portstrigger guys do some excellent write-up on all web attacks. What is an SSRF? It is a server-side request forgery, and it's basically where you can trick a web server making a server-side request to a local resource. It's a very strange kind of type of exploit, and it's basically connecting to itself. it's quite scary as well. So here's a quick example. You've got an attacker, your file, your website, and this, and then the website offers a webhook, and the webhook is supposed to talk to your own service that's somewhere else on the internet, but instead you put in localhost. So now this internal server is talking to internal resources. Whoops, you shouldn't be allowed to talk to that. So it's kind of funny because you spend all your time firewall-offing things, putting things in VPCs, trying to defend stuff, but then it's your own server that's attacking yourself. So that's kind of the way to think about it. In the wild, you can do some really weird things, especially on the cloud. You can grab IAM roles through the metadata address. You can leak IAM keys from the cloud using this attack, and then you can have those keys on your computer, connect to the cloud resource, and just start doing stuff in someone else's cloud instance, authenticated as that server in their cloud. I believe Prezi, the presentation software, had this class of exploits. So you can also list Docker containers, and if you're inside Kubernetes, oh my, you can grab things like API keys, config files, whatever you want. So exploiting this weakness. So we need a function in data power that gives us an SSRF attack. There's no way that would be built in out of the box. Here it is, built in out of the box. It's called the test message function. So you can enter a URL, it gives you this very basic form, and you can send a web request. And here is, can I make this full screen? I can. Is the Wi-Fi good enough? Yes. So this is me making a request to my own website, just kind of proving how the tool works. Data Power, Apple Pie. Data Power is quite designed for XML, so it kind of requires you to do XML messages, but you can see there in my Nginx logs that I'm getting a request to Data Power Apple Pie, and you can see all the headers returned and all that jazz, so it definitely works. So now I'm inside the Docker container, and I'm opening a Netcat instance to basically listen. So I'm pretending to be a web server in Data Power for debugging purposes. And then I'm changing it to localhost with exactly the same, I'm mistyping that there, so exactly the same thing. I'm going to make a call, and we can see the request is going in. So it's vulnerable to a server-side request forgery attack. If you look at Redis, Redis's commands are plain text. They're very boring, but interestingly enough, they're quite similar to HTTP, because in the headers here you have blah, 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 colon, and then something else, whereas in Redis, the commands are kind of the same thing. It's like thing, space, action. So you set apple pie, get apple pie, you kind of see this. So this leads to a different class of exploit called HTTP request smuggling. So where you can basically, through HTTP, make the protocol look like another protocol. So the idea is we're going to send a web request in HTTP, but we're going to embed inside of it Redis commands. Come on, other Tom. Talk faster. There we go. So here I'm adding in the request headers Redis commands, but sending them over HTTP. So here you can see the commands have been injected into the payload. What Redis is going to do is it's going to go, I have no idea what a post is, I have no idea what a connection is, oh, but I do know that, oh, I do know that, don't know that, don't know that. So it will execute these commands. And then an interesting kind of thing that you do here is the way that this test form is working, it's sending an AJAX request in the background. So you can open up the developer tools, and then particularly in Firefox, I have no idea why Chrome hasn't implemented this. In Firefox, you can just right-click on any web request. You can right-click on any web request. And you can click, edit, and resend, which is really handy. So then here you can just really quickly, if you want to quickly play around with a website, you can. And basically what I'm doing here is Data Power only lets you provide one-line responses. So here I'm using this ability to basically enter more data, and it just gives me a more flexible interface to Data Power's own API. it's more of just kind of a cool trick, but it makes this exploit a lot easier because data power is automatically turning things into headers by adding the colon. So with this, I just have a lot more flexibility. So that's kind of a crash course into server-side request forgery. Next slide. So there we are. So we've exploited weakness. We've kind of got a general idea of this. So privilege escalation. There's no way Redis is running as root. It's running as root. So no privilege escalation is necessary for this. Retaining access, it's a remote code execution, so there's nothing stopping us from adding a persistent backdoor of any kind. And we could possibly spend some more time trying to make this like really, really sneaky. But that's time you better take away. So let's write the exploit. It took about 2 hours. Wrote it in Golang. It just uses the standard library. And then we're going to run it. That's going to work first time. So here is the code. It's available on GitHub if you're interested. There's not that much to it. It's just we have the fake Redis server kind of implemented here, and then we have this library that I wrote to basically play with the data power test connection feature, which just kind of does that. And then here we have a little bit of C, which is implementing the Redis standard library to basically introduce a new command called data power shell, which then executes a shell on data power. So then I'm going to go to this one. So this is the full command. It's a data power Redis exploit. We're going to give the IP of data power, which in this case is localhost. We're going to give it that magic password. We're going to say that I'm going to be running the fake Redis, and then this is the module that we'd like to load into it. And hit enter. It just kind of does some things, and that's it. Bam. Got a reverse shell. That's it. And now I can just type ID, and I'm running inside data power. And if I do a PS, you'll see it's basically the exact same thing there. Something to note that I kind of skipped over. This is still an authenticated attack. You still need to be able to log into the data power GUI, and you still need to be able to run that test credential or test connection button. But it means you just need any login credential at all. So, and you're then inside an appliance which you really shouldn't have this level of access to, because natively it gives you a restricted shell. But yes, that's kind of the exploit. So it works. So that's it. So we've gone from 0 to SRF, and now we've got remote code execution. Any data power, anywhere on the internet. You need some form of login, as I said, but then you get full root access to this appliance that you really shouldn't have access to, and you can extract encryption keys or whatever you wanted from this appliance. Do whatever you like. So generate CVE score for this. Put it as an 8.8, which was my it's over the network. It's low complexity because it works every time. You need low privilege, no user interaction, and you kind of get everything because it's remote code execution. So I reported it to IBM through their HackerOne profile. This is kind of the timeline of events, and I've got a write-up of this on my website which goes through basically the initial report, asking them for an update. They come back to me, how you'd like to be acknowledged. They're working on a fix and stuff like that. But you can see, this took 4 months to fully get through, so you can kind of understand that when you find something, it's going to take a while for a fix to be rolled out. But yeah, it's officially fixed. There's a security bulletin about it. Got a CVE assigned to it, which is really cool. And it is really, really nice to go through this process, and you just get that one liner there saying that you found something. It's really, really nice to be acknowledged for the work that you did. So this is fixed in data power. You might want to look at it. I'm just going to leave it at that. So how does this impact the real world? So we are in the process of doing pen tests with our own software, and you know how I mentioned about that webhook exploit a while ago? Well, this sensor was not created by a webhook, so it can't be that. The interesting thing for this, particularly for me, is we did some threat modeling internally, full secure development lifecycle for this. We threat modeled it internally. We knew this was an issue. We created a library to explicitly handle this issue. We did tests on that. We built the library. We implemented it. However, it kind of failed in the integration test. So we were temporarily vulnerable to this exploit, but it's now been patched. And this is why you always follow with defense in depth. The right thing here to do is whitelist the domains, but also implement a series of protections like network protections, proactive network monitoring, isolation services, etc., which you can all find on OWASP. The point here is my personal security research that I did for this helped me understand and better mitigate this attack in the company. So that's kind of the moral of the story here. Before I close out, we are hiring. There's our careers website that's just been launched. Feel free to come along. We use a lot of very interesting technologies, very modern, and we're hiring for both the developers and to join the security team. Thank you very much. Any questions? Yes.
So your exploit to get a shell, you said there was no privilege boundaries between processes?
Yeah.
But it looks like when you run ID there.
Because it's running in Docker. So Docker natively, the way they built the container restricts it to that user. However, if you're running this on the physical appliance, then you get root.
Okay.
Yeah. Anyone else? No. Thank you very much.